Morning, ladies and gentlemen. Good afternoon, good evening, whatever the case may be. This will be our last little lesson in Algebra 2 this year. So take good notes. You will post these notes, and we will certainly review these properties again when we get into pre-calculus. But today, what are we going to do? Today, we're going to look at 3 important properties about logarithms. Okay? Before we get to important properties about logarithms, let's just review what a logarithm is. Here's what we know about a logarithm. Log base A of k is equal to n if and only if a to the n is equal to k. So a logarithm is just an easy way to write an exponential. I take this exponential, I have the base, I have the base, a to this, the output of the logarithm is an exponent. This is your exponent. A to the exponent is equal to k. That, ladies and gentlemen, is the definition of logarithms. Definition of a logarithm. Now we're going to talk about three very important properties. Property 1 is this. If I have log base A of k times j, this is a multiplication, log base A of k times j, what is that equal to? That is equal to the log base A of k, yes, indeed, ladies and gentlemen, plus log base A of j. So this is property number 1. This is a very important property. We call this the product property of logarithms. Okay, this is the product property, because what am I doing? I'm multiplying k times j, and this is called the product property. So you're going to be asked on some IXLs, hey, what's the product property? This is the product property. If you're taking the log of a product, what do? You take the log of base of k plus log base a of j. So you're going to add these two factors there. Okay, and what we're going to do, we're going to start off with a little verification, a little mini proof of this property right here. All right? So what do you know about this? We're going to start on this side right here, and we're going to end with the left side. Well, what do you know about log base a of k? Well, if I let that equal n, and why is this true? This is true because of the definition of a logarithm. Log base a of k is n. That tells me that a to the n is equal to k. This is definition. I just reviewed this. This is the definition of a logarithm. In like manners, ladies and gentlemen, if I have the log base a of j and I let that equal to m, that tells me that a to the m is equal to j. This also, why is this true? Because of the definition of the logarithm. So now I've taken log base a of j and let it equal m, log base a of k, let it equal to n. Guess what I'm going to do now? I'm simply going to take k times j. So I'm going to take k times j. And what is k times j? Well, k is equal to a to the n. J is equal to a to the m. And now I'm multiplying like bases. And so k times j is equal to a to the n plus m. This is the exponent law. This isn't law of, this is what we did last unit on exponents. If I have a to the n times a to the m, that's a to the n plus m, like bases, add the exponents. So what does that tell me? That tells me that k times j is equal to a to the n plus m. Now, what do you think I'm going to do? And keep in mind, if you ever want to pause the video and catch up on your notes, you may have to do that. You can pause in a YouTube video. I know that you can. So guess what we're going to do? We're going to take this statement right here, and we're going to write that with the logarithm, because I have the base This is my exponent. The logarithm equals the exponent. So I have a to the n plus m is equal to k to the j. That says log base a of k times j is n plus m. Well, what is n? N, we let be log base a of k. What was m? Log base a of j. And that, ladies and gentlemen, is the verification of the product property of logarithms. You will need that on your IXLs. Okay? And I'm going to show you how we apply this particular property in a couple slides coming. But now I'm going to go over the quotient property of logarithms. You will need to know this on the IXLs and next year. For the rest of your mathematical career, you will need the quotient property of logarithms. And we're taught it's the quotient property because look what I'm doing. I'm taking the quotient, log base a of a quotient, k divided by j. What does that equal? Oh, that's weird. It is weird. It's a very simple verification. That says that log base a of k minus log base a of j is equal to the log base a of k over j. And guess what we're going to do? You guessed it. We are going to verify this particular property. Again, this is a very important property. What do you think we're going to do? You betcha. We're going to let log base a of k equal n. So we're going to let this guy right here be n. And we're going to let this guy right here be m. So log base a of k is n. We're going to let log base a of j be m. Alrighty. And what do you think we're going to do? We're going to do this. It's going to be the same type of verification as we did previously on this video. What are we going to do? Well, we're going to try to get this screen down there. By definition, this, ladies and gentlemen, is the definition of a logarithm. Definition, what do you know? Well, a to the n is equal to k. A to the m is equal to j. This is by definition of a logarithm. Alrighty? So what do you think we're going to do? Well, we're going to take, same manner, we're going to take k and divide it by j. So what is k divided by j? K divided by j is the same as a to the n divided by a to the n. K is a to the n, j is a to the m. So k divided by j is the same as a to the n divided by a to the m. And now we know by the exponent law, like basis division, that's going to be a to the n minus m. So what statement does that give me? That tells me that k over j is equal to, that's freaky how that does. I don't know why that does it, but it freaks me out. That equals to a to the n minus m, because I'm simply going to go from here to here. And what do you think I'm going to do? You guessed it. I'm going to use the definition of logarithms. And I'm going to write this base a, log base a of k to the n is equal to the exponent. This is the exponent. So log base a of k divided by j is n minus m, definition of logarithms. Oh, well, what's n? Oh, well, n is log base a of k and m is log base a of j. Guess what I have, ladies and gentlemen? That was kind of freaky. You betcha. I have the quotient property. This guy right here we let equal n. This guy right here was equal to m. So this is the quotient property of logarithms. The IXLs will ask you, hey, what's the quotient property of logarithms? And you will say this right here. Okay? So thus far, we have the quotient property of logarithms right here. And we have the product property of logarithms. The product property of logarithms, if you take the log of a product, it's the log of each factor added. You multiply the parameters, you're going to add the logarithms. Boop, boop. If you divide the parameters in there, you're going to subtract the logarithms. And one more property we're going to look at, because keep in mind we were going to look at three. Well, before we do that, let's do a couple examples how we use that. Okay, so this is an application of the division. Is this the one I want to do yet? No, we want to go here. The application of the product property. And as always, I'm going to write this down so I know what's going to go on. This is what I'm going to use. And look what I have. I have the log base 6 of 9, which I don't know. 6 to what power is 9? I don't know. Log plus the log base 6 of 4. 6 to what power is 4? I don't know. But look what I can do. I can use this product property, and I can do this. This is going to be the log base 6 of 9 times 4. 9 times 4. Well, what is 9 times 4? That's going to be the log base 6 of 36. What? 6 to what power is 36? That's 2. So this certainly doesn't look like 2, but guess what? It is. Why? Because of the product property of logarithms. All right, let's do another example using this product property of logarithms right here. We're going to use this property. All right, so we have a log base 8 of 2 plus a log base 8 of 4. We don't know what that is. We don't know what 8 to what power is 2. We don't know. 8 to what power is 4. We don't know, but guess what we can do? We're going to use that product property. That's going to be log base 8 of 2 times 4, which is log base 8 of 8. And 8 to what power is 8? 1. Does that look like 1? It does not. Why is it 1? Because of the product property of logarithms. Okay, so let's do some more application problems here. Here we go, application of the quotient property. And look what I've done. I've rewritten the quotient property, log base A of k divided by j is equal to log base A of k minus log base A of j. I'm going to apply this property. What do I have? Log base 8 of 16 minus log base 8 of 2. Oh, what is that? I don't know. But guess what? I'm going to use this particular property and figure it out. So what is this? This is going to be log base 8 of 16 divided by 2. K divided by j. And what is 16 divided by 2? 8. And what's the log base 8 of 8? That's equal to 1. So you would not have thought that that was 1, but by the quotient property of logarithms, it is indeed 1. One more example here. What's going on? Get over here. Okay, this is a big, maybe we might not be able to do this one. The log base 6 of 1080 minus the log base 6 of 5. I'm going to use the quotient property. Log base 6 of 180 divided by 5. Hey, use your calculator. What is 180? 1080 divided by 5. That is equal to log base 6 of 216. And guess what? 216 is 6 to the third power. 6 cubed is equal to 216. So a couple applications of the quotient property of logarithms. And we're about finished, but we're going to have one more property, and this is going to be the power property of logarithms. Keep in mind, ladies and gentlemen, if you ever need to pause the video, just pause it. Just pause the video, please. Okay? Okay, this is a peculiar property, fairly easy to verify. So we have the log base A of k to the n. We call this the power property because if you notice, I have k to the power of n, k to the power of n. Well, that's going to equal, all I'm going to do is take this power and put it down in front. So the log base A of k to the n is equal to n log base A of k. Pretty easy property. And it's a fairly easy thing to verify here as well. So if I have log base A of A to the n, what does that equal? Well, it asks a question. A to what power is equal to A to the n? Well, that's going to be n. It has to equal n. This has to equal n. Why? Because A to the n is equal to A to the n. Well, if I use the power property, I have log base A of A to the n is equal to, I'm going to take this exponent here and pull it down in front, and I have log base A of A. What is log base A of A? That's equal to, ladies and gentlemen, that's equal to 1 times 1, because this guy here is 1, because A to the 1 power is 1. Okay? So let's just do another simple little application that doesn't come out so nice. Oh, I have log base 2 of 5 to the 7. All I can do with that is write it this way. I'm going to take this exponent and I'm going to write it down in front. That's going to be 7 times log base 2 of 5. And you know what? I really cannot simplify that. That's fini, done, over. That's all you can do with that rascal right here. And then our last example for this particular video is I'm going to use the power property. What do? I take this exponent there, move it down in front. So that's going to be 3 times log base 2 of 4. Oh, this one I can evaluate because I know what this is. This is going to be log 3 times log base 2. What's 4? 2 squared. 2 to what power is 2 squared? Pardon me. 3 times 2, and that is equal to 6. So you're going to really need to know this is simply equal to 6, what this guy is right here. This video went over 3 properties. It went over the power property, things that you're going to need to know on IXLs. This is the power property. You simply bring the power down, the exponent down in front. That's the power property. Then we had the, back here, we had the, well, right here it was. This is the quotient property. You divide, you're going to subtract the logarithms. And then we have the product property. If you're going to multiply inside the parentheses, it's going to be the addition of the logarithm. So that, ladies and gentlemen, is your next lesson. We certainly will review these properties next year in pre-calculus. So I will talk to you later.